Welcome back to CAD Level 2, Assemblies and Design for Manufacturing. In our previous module, we applied some tolerancing to our joints so that they could be more easily manufactured and so that their constituent parts would fit together smoothly. Now, let's create a dimensioned drawing that we could take to a manufacturing center to fabricate our part. At the foot of our document, I'll use this Insert New Element symbol to create a new drawing. When I do, certain standardized templates will appear. I'm going to pick the default template, ANSI A inch.dwt. Before we get started, I want to clarify that the drawings that I will make in this demonstration are intended to show off the functionality of Onshape drawings. While I'll try my best to adhere to the standards that you should consider when making any standardized drawing, the fact is that showing all of these features at once is going to overcrowd my drawing space. So, again, let's take a look at all of the drawing features that we have available to us. And I'll leave it up to you to refer to the resources available on the ITLP CAD 2 Assemblies and DFM website, which include links to resources which outline the rules and guidelines of making dimensioned drawings. So, without further ado, we notice that the first window that opens up upon creation of our drawing is a Select a Part or Assembly window. In it, we have a list of all of the parts and assemblies that we've created in our document. Right now, the only two parts are Joint A and Joint B. Let's create a view of Joint A. When I click on Joint A, I'm given a projection of my part. Right now, as indicated in the Insert View window, my view orientation is front. When I place this, I'm offered several different projections of my original part view based on the position of my mouse. Each of these positions indicates the top, front, right, left, back, and bottom views with respect to the front view that I originally placed. Let's place a left view projection next to my front view. In order to create more projections, I need to use the Projected View tool located up on the toolbar. When I click this, I can select any of the views that I've previously placed to project from. Some of the views that we'll be interested in, other than the front view, are the left and right views, since their holes and the countersunk features that surround the axle are different on either side. I may also be interested in the base to show that it's square. One of the key rules of dimensioned drawings is to present and label everything that's necessary and nothing more. Effectively, we are trying to accomplish the same thing as we do when we are creating a fully defined sketch. We want to show all of our features, and we need to label all of the dimensions needed to create this part from scratch. However, we want to avoid duplicating any dimensions. We also need to label these dimensions and these parts clearly. To do so, it might be useful to enlarge these parts. One interesting thing of note is that these parts are represented to scale. The sheet of paper used in this drawing template is a standard paper size called A. You can see that down here in the bottom right-hand corner of the title block. You'll notice that the scale of the entire drawing is 1:1, so what we see here is a true-to-scale version of what we are making. However, it's not specifically necessary, nor is it often practical to retain the 1:1 scale. So, let's adjust the sheet's scaling factor. If we right-click anywhere, we get two properties options, Sheet Properties and Drawing Properties. Click on Sheet Properties to pull up things like the scale, the format, and size of the standardized drawing sheet that we're using. Here, let's change this to 1.5. Now things are a little bit bigger and more easily read. We can move the projected views around, and they will stay aligned with one another, maintaining this orientation of standardized orthographic views. Now, there are a few features of our part that are not visible by these standardized orthographic views. One might be tempted to address these features using an isometric view. However, an isometric view should never be labeled with dimensions in a dimensioned drawing. It should only be used as a visual reference to give a greater picture of what the part looks like. With that in mind, I will place a new isometric view down in the bottom left-hand corner of our drawing, but this will only be used as a visual aid. In order to view the details that are hidden inside of this part, it's useful to create a section view. The section view tool allows you to pick a section plane and generate a section view projection of that part cut at that section plane. Now, this A section view is represented by this cross section, which allows us to see the internal profile of our axle channel. One other section view that might be useful occurs here. Now, I can see the internal features of the channel between the two lobes. Let's space these views out a little bit. Before we start dimensioning, let's take a look at a tool that allows us to see detailed features more up close. The Detail View option allows us to define the center of a viewing window in the shape of a circle. This detail view can be placed anywhere on the drawing. We can change the scaling of this detail view by double-clicking on it and changing the scale here. Let's keep it at 3:1. Again, you'll notice that each section view and detail view are labeled with a corresponding letter. While these views allow us to see more detail of our part, it does clutter up our space, and so it's going to be important for us to be careful about where we place our dimension labels. Let's start that now. To begin annotating dimensions, click on the Dimension tool. You'll notice that there is a drop-down menu that allows us to pick specific dimensioning types. However, the generic Dimension tool is a sort of catch-all. The dimensioning tool here will act much in the same way as the dimensioning tool found in the Part Studio. I'm going to begin dimensioning now, without much explanation or narrative in between. However, I want to emphasize the importance of maintaining clear and non-crowded drawing labels. Dimensioning balloons should be kept away from other lines and should not duplicate dimensions. Also, consider the person reading this. Don't make the reader do math. The key phrase to remember is be concise and complete. Now that I've labeled most, if not all of my dimensions, let's talk about some more specific, specialized dimensioning tools. You'll notice that I did not dimension the internal through hole made for our axle. That's because this hole is specifically meant to accept an M4 metric screw. Up here in the toolbar, you'll see a hole callout tool. The hole callout tool will generate a more descriptive hole label, describing, among other things, the type of screw and the type of hole to be created. It also looks like I've missed dimensioning the hexagonal profile for our nut. While I can use the dimensioning tool to call out the size of the hexagon, I need a way to describe the fact that this hexagon lies in the center of this greater arching lobe. To do that, I can use a symbol called the center mark tool. This places a small crosshair in the center of any circular profile. Since our axle hole lies in the center of this overarching lobe, placing this center mark tool is an easy way to describe its position without enumerating it. On a similar line of reasoning, we can use a center line to designate that the holes for the screw and the holes for the nut are in line with one another. Now that we've placed all of the views and all of the dimensions that we need in order to completely replicate this part from scratch, let's finish this drawing by completing the title block down in the bottom right-hand corner. If I hover over these cells, you'll notice that an alternate text appears, stating that this is a sheet reference to Title 1. Similarly, on other fields, we get sheet references to Title II and other things like drawing part number. Rather than editing these items directly, we can edit the metadata that is part of the document properties of both the sheet and the parts that this drawing are made of. So, in order to update the title, I'm going to right-click on the Part Studio tab for Joint A and select Properties. The dialog window that appears has some familiar text fields, including Title I. However, I'll have you know that we need to select Joint A as a part rather than the Part Studio. We're editing the metadata for the part rather than the document. When I move into this Joint A part, I can move down, find Title I, and call it Joint A. When I return back to my drawing, I notice that despite having updated the text, haven't been populated. That's because any time I edit a part that's represented in a drawing, the drawing will not automatically update until I've manually updated the drawing using the Update from this workspace tool. Clicking this will update my drawing, including the metadata, filling in the text for Title I. Before we finish, let's say I want to create another drawing for my second joint, Joint B. Rather than creating an entirely new drawing, I can add a sheet to this drawing by clicking this tab. Up in the top right-hand corner, I can select Insert Sheet, and a new sheet nested under my first sheet is created. Now, in order to place views for Joint B, I notice that Joint B is not available in my Use Existing drop-down menu. I need to insert it first by selecting Joint B from my parts list. At this point, we know what to do. This concludes this module for CAD Level 2 Assemblies and Design for Manufacturing. In our final module, we will debrief and summarize all of the things that we've learned.